Welcome to the shop. This video we're going to build up the x-axis. Now off camera what I've done is I did find that when I put the gantry on, this side was about a millimeter lower than this side. So what I've done is I've just, and it's easy to adjust then, I just filed these holes out, alright, about the same amount, about a millimeter, and it's taken it down. It's now perfectly aligned, and it's perfectly square now as well. So that job's been done. However, I'm going to take it apart now, just on one end here, because I'm going to put the rails on. Now, I have made about 50 or 60 of these. A lot of people buy the T-nuts to go in here, but you know, I'd like to make as much as I can myself. And you know, really it took about half an hour just to cut these off and drill them and tap them. And so these are my T-nuts. Which are going to be backed up on the linear square rails, and also a job that I need to do to get the linear rails on. When I ordered my linear rails, to cut cost, actually, I ordered 2 sets of 1500 long, which is 5 foot. If I'd have ordered a 1200, which I require for the x-axis, they would have charged me $30 cutting fee. They don't tell you that, but if you sort of go into the if you order them online and look at the price of 1500, 5 foot long, is X amount of dollars, and then you look at 1200, you would expect them to be cheaper, but they're not. They're $30 more. So, you know, I got the equipment here, and really all you need is a small angle grinder with a slitting saw, because the idea is that this is hardened steel, these rails, and the idea is to cut it through accurately, but put as little heat into the metal as possible. So that's why you use a slitting disc. Actually, I'll get one. Okay, this is a normal cutting disc. Okay, 4-inch cutting disc. Now this is a slitting disc. Okay, notice the difference. They're very much smaller. This is 1 millimeter. Okay, about just over 1/32 of an inch. So you know, you only cut in with the tip of this. It's a very narrow cross section that you're cutting with, so it doesn't build up so much heat in the material. So that's what we're going to do, is measure this now, and we'll cut them off and clean the end up to fit on our x-axis. Notice that the steel hasn't blued at all, maybe just right on the very tip there. So we haven't changed the steel structure. a very hard, very good file. This is one for a chainsaw actually. Right, so I've just cut this ball screw off to length, and now I have to machine this down to 10 millimeters actually, which is the size of the rear bearing. And because this is so long and hangs out the lathe, now this is a type of arrangement that you sort of have to adapt. Now I've just taped up the ball screw there, and this is a fairly heavy duty rack, and I've just screwed a block of wood on the top here, and I'm using the bearing to hold the other end of this shaft, because I'm going to be spinning this up about 1500 RPM to be able to machine the bearing end. And I'm using the bearing here. It's a dual bearing inside here, and I've screwed this to this block so the end of the shaft doesn't whip around, okay, because I have seen something like this, although this is a very tough bit of steel. Once you get this spinning up about 1500 RPM, it'll tend to whip around like this, and sometimes, and I have seen it, the gravity sort of inertia, centrifugal force takes over, and it can bend this like a 90 degree. I haven't done it myself, but I have seen it done. So to avoid all that and keep this running all nice and true, I've supported this end using the bearing. So let me just spin it up. So that is the type of arrangement. So now I'll just machine this down. Like I say, I've got to come down 10 millimeters to 10 millimeters. This is 20 millimeters at the moment. There is two types of material here actually. The outer part of which the thread, or where the actual balls run on the threaded part here, this is extremely hard. So you've sort of got to get underneath this, and you've got to get this off first. And the center, or the middle part of the material here, is softer. So it's quite deep. I suppose you could call it case hardened. So yeah. So here we go. Well, that's perfect. I've allowed myself 1 millimeter clearance here between where the plate is going to be and the end of this to give me maximum travel here. In other words, to fetch the bearing block as far this way as I can. However, there is a small problem, and I'll just get the camera and I'll show you what that problem is. And what the problem is the holes, the retaining holes for this bearing block don't line up at all with the center of these recesses here. So what I'm going to need to do is put a aluminium block on here and screw this to the aluminium block, and then use the or have bolts in the aluminium block going down through to the center here. You only need a couple of screws in here. I may put 4 in there. It's just unfortunate that you know, if I put a bolt through here, I'm going to have to take some of this side wall out. I could do that. I'll have a look at it, but my first thought is just to put a little 6mm or 8mm block of aluminium on the top here. You know, I've got plenty of room to do it. We'll have a look, see what we can do.